Hello everyone, welcome to this session. In the previous session, we have learned about the different metrics of evaluating a model. So here in this session, we will see all the different metrics programmatically. So for this, we are using this Jupyter notebook here. Okay. So first of all, we will see the metrics for the classifier model. So here I am here in this code, I am using the logistic regression model. You can use any of the regression model and you can analyze the which matrix is good or not. Okay. So this logistic regression, don't confuse with the word regression here. This is a classifier model. So now I have imported this regression model from the sklearn package. And then I've imported this train and trend rest split model. And again, we have imported this panda NMP, which I will be used later here. Again, I have imported this accuracy score from this sklearn matrix. Okay. Now, this read CSV file, I'm using this function to load the CSV file. So what does it contain in the load.csv file? We will see here. So here, there are the three columns here. This x1, x2 is the coordinate of the point in the form of xy. And this y denotes the state of the point, whether it is positive or negative. And it is in the form of 0 and 1. 1 means positive and 0 means negative points. Okay, now let's see. So here what I have done, I have loaded this CSV file. Now we am taking this two column x1 and x2 from this data framework, and creating the numpy array and stored in the x variable. Again, I am take the y column and create a numpy array and store in y variable. Okay, so now what I am doing, I am splitting the data into the training and the testing set. Okay, so for that I'm using this train test split function. Okay, where I'm giving this test size value equal to 0.25 means 25% of the data is used for the testing purpose, and this random state equal to 42 means how random you want to pick the data for the testing and training set. Okay, so run this. Okay, now coming to this part. So in the previous session, I have already explained about how to plot the data in the graph. So here I am using this matplotlib package, and where I am creating this, I am plotting the graph here. So here you can see this red points are the negative points, which I have mentioned here. If it is negative, it will display as negative red color. If it is positive, it will display as blue color. Okay. So now what I'm doing, I'm defining this classifier, and I'm fitting this fitting the data to this model with the X train. I have trained trained the model with this X train and Y train. Now, in order to test the data, so what we are doing, we are using the predict function and giving the argument X test, which will predict the value of Y. So the predicted value with the predicted value is of y is placed in this y predict. Okay, I have also printed this y predict here. Now with the accuracy score function, what I'm giving the argument, that is y test, that is the true value of y, and with the predicted value of the from the model what you get. So how much accuracy you are getting here. So if I run, I have not run this one. Okay, so now if I run this, so I'm getting 58.33% of accuracy. Okay, that is not much high value, but we'll see. Okay, now for the F1 score, I've imported this model and used this function and giving the passing the argument this y test and y predict, where F1 score giving the importance to both precision and recall. So if I run this, if I get the 73.6%. Okay, same for the F beta score also, we will pass the argument, and even we will give the beta value also in the argument. Okay, which means we are taking the score which is very close, which is close to the precision. Now if we run, you get this much percentage. Now you can try this all this metrics with a different model also, like decision tree, SVM, etc., and you can find you can compare the accuracy F1 score and beta score with all this model, and you can find out which model is best. So now you have seen about the classifier matrix. Now we will see to the regression matrix. So here also I've imported everything here. Now same CSV file I will be using here, but as you know, regression finds a numerical value. Okay, so for that what I will do, I have not created another CSV file. So what I will do here, I will predict the value of x2 depending upon the x1 value. Okay, we will forget about this y column here. Okay, so now coming to here, so I loaded this CSV file. Now I will pick this column and create a numpy and store in the x variable. Same way for x2 also, creating the numpy and storing y. Now we have splitted the data with train and test. Here is testing set. Now we are using this linear regression model here. Okay, so linear regression model I'm using. I have created. We have defined this model, and then we have filled the all the data with the we have trained the model here with the y train and x train. Okay, now in order to find the mean absolute error, you will import this from sklearn. Now we will test the data. Okay, we will use a predict function and give the x test as argument. It will predict the value of y. That means x2 value will predict depending upon the x1 value. Okay, now we will check how much error we are getting with the y true value of y and predicted value of y. Okay, so we have passed this to argument and we'll find this error. So I have not run all this. Let me run. Okay, we get this 23% of error here. Now for the mean square error also we will import this and use this function, okay, to calculate the error. Now if we run this, we get this much error. Now if for the R2 score, we will import it and we will call this function to predict to find out the how much error we are getting. So this all the different metrics to evaluate the model for the regression model. Okay, so here I have used a linear regression. You can use decision tree or SVM, anything you can use, and you can find if the error is less for that model, then you can use that model for this for your particular set of data. Okay, so that's all for this video. I will see you in next video. Thanks for watching this video.